Okay, everyone, I'm going to get started now. Thanks very much for joining our webinar today. The goal of this webinar is very specifically to get you started with Structure 101 Workspace. Some of you may already be familiar with Structure 101 Studio. So I won't be saying too much about Studio. This is very much about the relatively new product called Workspace. I will talk a little bit, if there's time towards the end, about how you would use Workspace and Studio together, because there's cool stuff you can do there. Okay, so I'm going to show Studio or Workspace is installed as a plugin to either Eclipse or IntelliJ. At the moment, it's specifically for Java developers, although you can use it with other JVM languages such as Scala. And so the way you would install it typically is the way you would install any other plugin. So the sort of safest way that kind of works for both IntelliJ, or the least hassle way, for both IntelliJ and Eclipse is if you go into your settings here, plugins, if you go to our website and download from the website, you'll see, you'll download a zip file and then just install plugin from disk. That'll always work. You can also go to the repositories and that type of thing and get it direct from Eclipse and or IntelliJ. But your best bet really is to download the zip file and then just to install plugin from disk, and you just point it to wherever you download it. Okay. And when you install, so let me go have a look here then. When you first install IntelliJ, this is what you're going to see. Basically, you're probably going to see a blank screen. Okay, you'll see there's a new viewer here called the structure map, which I'm looking at here. It starts off empty. So what you need to do there is you need to decide if you're going to have automatic updates to your structure map, or are you going to let Workspace decide whenever you do a compile to refresh the view? And that kind of comes down to how do you do your builds, how do you compile your code, and so forth. In order to populate the structure map, you just click this full refresh button here. And then it'll sort of take a little while, depending on the size of your workspace. And then something will appear in the structure map screen, okay? And I'll talk about what you're seeing there in a minute. Sometimes you may still have, even after doing a refresh, you may find that you still have a blank screen there, okay? And the reason for that is what the structure map is doing is it's taking you to wherever you are in the source editor. It's letting you just see it's navigating to that. I'll explain what that means in a moment. But if for some reason you have something that is not a Java file open in your IDE, then it has nowhere to navigate in the model. And therefore, what you probably just need to do is hit the home button, and that'll take you there, okay? I'm just going to reset my demo a little bit here. None. So what I'm going to do now is I'm going to walk through the demo of how you would use the Workspace plugin and so forth. What I'll do is I'll take questions at the end. So if you have questions at all, please just put them into the Q&A bit of the Zoom GUI that you have open there, and I'll hopefully have time to catch any questions at the very end is the easiest way to do it. Okay. Okay, so what are we looking at here? Let me just show you. I suppose typically when you are working within IntelliJ, this is our own code base here actually, and you see on the left-hand side, you have the outer structure of the IntelliJ workspace, which is all of the modules that we organize our code into. And in Eclipse, they're called Eclipse projects, listed in alphabetical order on the left-hand side, okay? Now, when you install IntelliJ, when you install Workspace, you're going to see this Structure Spec viewer here on the right-hand side. And the first thing you're going to see is basically all of the modules in your workspace, okay, but organized in this form here, okay? Just by the way, you'll notice that I'll be continuously panning and zooming this viewer here. And what I'm using here is the same gestures that you might use for Google Maps. So I can just grab and drag to move things around. In this case, I'm using a mouse wheel to zoom in and out, but you can use trackpad gestures or whatever. So the first thing we're seeing here, or as I said, is all of these, instead of alphabetical listing here, we have this sort of alternative, what we call a levelized representation of the top level modules. So you can see when I mouse over, I'm seeing the dependencies of each of my modules here appears when I mouse over any of these items, okay? So this is a levelized representation, which means that core here is sitting at the bottom simply because it doesn't use any other modules. It's used by a lot of modules, but it doesn't use anything else. It goes on the bottom. And then on the next row or the next level, we're seeing a number of any modules that just use core, but don't use anything else. And then we got on the third row, we're seeing anything that uses something on the second row or the bottom row. But the bottom line is that basically everything uses at least one item from the row immediately below it. Okay. The other thing you can do here then in the structure map is if I command click or control click on Windows, any of these items, it does this. You can see it got a lot smaller. What it's doing is it is spotlighting, this is called. It's filtering the structure map to just show me anything that has a relationship with the thing I just spotlit. So I'm just seeing anything to do with parser.net here. If I command click again, it unspotlights, and I can do something here. Okay, same thing. I can spotlight any item here to just see the world according to whatever it was I just spotlit, okay? Next thing I'm going to show is if I just click on any of these items, they expand and I look inside them. Now what I'm seeing here are the packages inside the modules. So I went inside core here and I'm seeing COM. And if I look inside Headway, I see these are all the sub-packages within Headway, okay? Again, they're levelized at each scope. So within the Headway package here, com.headway, I see logging is at the bottom because it doesn't use anything else. Util uses logging. Brands and foundation are side by side because they don't use each other, but they both use util, okay? And then above that, I've got this slightly different thing that I haven't described yet. It's called a tangle. This is basically where I have 3 packages here that are cyclically dependent. That means they're all in one, they're either directly or indirectly dependent on each other. And when you have a tangle, you cannot strictly levelize the items within the tangle. So what Workspace does here is it levelizes them in such a way that as few as possible dependencies flow upward. So you can see here, there's a dependency that flows upward, there's a dependency that flows upward, okay? So this is important because, well, cyclic dependencies are generally something you want to avoid, but from a visualization point of view, where you have no tangles and no feedback dependencies, you know that the dependencies all flow downward, okay? So even when my mouse isn't over anything here, I know that for the most part, all the dependencies flow downward. But I also know that to be wary that within that group there of 3 packages within the tangle, I cannot be sure that all the dependencies flow down. And in fact, it always shows me the feedback dependencies. Those red lines don't go away when I take my mouse away. And there's a red box around it. So I just so that you kind of know exactly at a glance what you're dealing with in terms of your structure, okay? So I'm going to drill down a little bit further now. And I go inside this package here. And now things are getting a bit busy, as you'll observe. And at this point, I'm seeing a whole load of classes and interfaces are starting to appear. Okay, that's okay. And I can, at any point in time, I can command click, let's say I command click this class here. You'll see what happens when I do that. A lot of stuff went away when I command click the class. You see all of these modules at the top here. When I command click or spotlight the depot proxy here, it gets a lot smaller. And what I'm seeing here, because I'm now down at the code level, I'm seeing here all of the other classes that depend on depot proxy, wherever they are in the structure, okay? And likewise, the things that depot proxy depends on, okay? And now I'm going to drill into a class. And here I see, I'm going to command click now on this depot proxy here. This is one of the constructors. And you can see it drastically reduces, it removes a lot of stuff from the structure map. Okay, when I alternate the spotlight here, all of the whole code base is shown at the moment because nothing is spotlit. When I spotlight that item, I'm seeing now right down to the method level, I'm seeing all of the classes, methods, and fields that reference whatever it is I just spotlit, okay? So this is how we get a feel for, well, first of all, you're seeing all the dependencies of a particular item within the visualization here, but you're seeing it through the package structure in this case, okay? And you can walk around. If I command click, for instance, on the get instance here, I can see what is its set of dependencies. Get location, okay? I can move around the code base in this way. Save, okay? And when I'm here, I can just sort of command click again, save, to see what else is around the save. See the full picture here. Okay, let's go back to just see the spotlight environment there, okay? And at any point in time, if I want to look at any of the code here, I can just alt-click on an item. So if I see alt-click on this execute method here, you can see it takes me over here. There's the execute method. And you can see somewhere it should be a dependency on save, which I can see is right there. Okay. And at any point, if you want to, if you can walk a bunch of dependencies around the code base, then you can kind of retrace your steps. I'm just clicking the back button here. Okay. And it takes you back to where you were. Okay. As you might expect, you can also navigate at any at any point in time here. You can show any item in the structure map. Okay, so you can go in that direction. Okay, that's easy to do. But the other thing you can do is you can automatically follow from your source code. So if you're browsing around, this is very useful if you're browsing around your source code, you just click that button there, and wherever you go in the source code, it will spotlight that item. So you can see that item's dependency environment, okay? And what you're seeing here, just to sort of remind you again, this clear method, I'm seeing that it doesn't depend on very much. It just depends on one local function here or method within the same class. But it's also being dependent, it's being used by these other classes around here, some of which are in different modules. Okay? I'm getting the subset of the overall architecture and how it depends on very detailed down to how it depends on the item that's spotlit. Okay. Now, what happens when I start changing some code? What I want to show you here is I'm going to drill into here again. What I'm going to do here is I'm going to create a small dependency in my code base here. And where I'm going to create it from is I'm going to make it so that there's effectively, I want to create a dependency from foundation to brands. So what I'm going to do is drill in here, and inside metrics here, I have this elementary metric. Okay. And I'm going to make a dependency from here. I'm going to create a field within elementary metric. I just give myself a little bit more room here. Okay. So I'm going to create a field within elementary metric of type branding. Okay, so how am I going to do that? Actually, first of all, I'm going to switch on just the auto refresh here. So it's the visualization when I make a code change will automatically update. So I click on that. I'm going to switch off the following just to keep things a little bit same. And now I'm going to just go to this elementary metric file here. So I alt click on it. Takes me here. And what I'm going to do is just unspotlight, sort of uncomment this public branding brand line here. Just give it a minute and it should update. And we'll see what we see there. So there's a few things that happened when I did that. The first is you can see this new field here. The F icon indicates it's a field. Called brand. Okay, so that's now inside this class here. The other thing I'm seeing is that there's a new dependency here on the branding class. Okay, that's because that is the type of that field. Okay. The other things I notice is that both brand and the dependency here are colored differently. They're in a kind of purple color, indicating that they are new. Okay. And the final thing I noticed was that when I created that dependency, this brands package moved. It was re-levelized now because there's a dependency here. The position of the brands package moved down. Okay, so a few things I want to do there. I want to show you again what that happened. I want to show you that at this level here, however. So let me even just go right back to here so we can see at the package level what happens. So if I go here and I just undo that change, I just comment out that that new field, and you'll see brands now is back beside foundation. Okay, and I'm going to redo the change here and give it a minute, and I see that there I have something has changed. It's purple inside foundation. And there's a new dependency, the purple dependency between foundation and brands. Okay, so I'll just undo. Redo. So you can see you're getting a constant visualization of your code base as it is right now, and it's being color coded with any new stuff that you just created. So you're always going to start being aware now, right up at the package level or even the module level, when you make structural changes that change things. And the higher you go up through your packages, ultimately to the module layer, you're starting to impact things. If you create a new dependency up at those levels, that's becoming more significant. It's becoming more of a architectural change rather than a simple code change. Okay, so that's something you kind of need to be aware of. The newness indicator here, you can very easily drill down to say, well, where does that red thing, where does that new dependency come from? You can drill down and see it very easily here. There it is right there. You just drill down into the structure to get more detail. Okay. The other thing is that the newness is kind of like a sticky bit. At any point in time, you can clear the newness with this button here, this sort of star here, clear the newness indication. If I click that, it'll just refresh and the purple newness indication has gone away now. And from now on, anything new that I do will be purple until I click that star again, okay? Okay, so far we've done nothing. All this visualization, we've done no laying out, we've set no rules, we've made no, we've done no real work. This is all just, we just installed this 10 minutes ago and we're browsing around the code base, okay? When you're ready, you can actually start now, you can create what is called a structure spec. And what a structure spec is going to do is to do that, you're going to click this edit button here. And actually on my other monitor here, it's going to open up what is called a structure spec editor. Here it is. Okay. And this allows you to now to lock in place the top level arrangement of your modules so that they will no longer float. When you create new dependencies between modules, they won't just float unless you explicitly move them inside here, okay? And you can move them just by dragging and dropping. So I can change the position of things here very easily, okay? And I'll come to that in a minute. But the first thing, if I just do nothing else and I save this structure spec now, I'm going to be going from a situation where we had no structure spec to one where I now have a structure spec. Now, in fact, the structure spec says, you know, don't change anything. That's fine, okay? But you'll notice here that these lines have appeared between the modules. That just means that they're not going to float anymore. They're locked in place. They are now specified. When I drill into like core, into the package structure here, you'll see there are no lines. These are still as they were before. So these will continue to float, okay? But up here at the top level, they will not float, okay? So the sort of thing that can happen here then is when I create a dependency from one of these to another, they're not going to, I'll do that right now. So I'm going to alt click on here, where's my project here? On build tools. And I'm going to add a dependency from here to one of the module dependency to, let's say what is the one next door to it. I think it's this one here. This one here. Okay. There's something you'll notice now that'll happen here when it updates, is that you'll see a new dependency here from build tools to addition CEA for CVA, right? The one next to it. Now, when I did that kind of thing before, build tools would have just floated up above addition CAA for CVA, okay? In this case, it didn't do that because it's locked now. It's now specified. I have said, in effect, the build tools should not use this, and therefore I've got this line here. Even when I clear, notice when I clear newness here, the dependency from build tools to addition CAA for CVA is still there. It doesn't go away, it turns red. That means it's a violation. I am violating the spec. Now, what would I do about that? Well, I might say, well, actually, that's okay, okay? And the way I say that that's okay is that one way to do that is to just move it up in the spec, hit save, come back here, and now build tools is sitting above it, and there's no violation, okay? So we're all happy now, okay? But I can actually be, so that's based so far, that's just doing what it would have done before I had a spec, okay? But now I'm going to get a little bit more specific. I'm going to say, well, build tools is using this package, this module here, okay, which is okay. But actually, I don't want it to be able to use the other ones. I'm going to say that it should not use addition KW for CPP and the others. And the way I would do that is to, and if you follow here along here, I'm going to do a few changes here. I'm going to grab build tools and the one that it does use. Let me just hit refresh, Command R. Build tools And additions, which one is it here? It's the one I wanted to be able to use is CAA for CVA, okay? So I'm gonna hit Build Tools, CAA for CVA. I'm gonna right click, create a wrapper around those two. So I'm grouping them together in a logical way. From a dependency control point of view, I'm saying these are grouped together. Build Tools can now use addition CAA for CVA because it is above it, okay? Dependencies are allowed flow downward, so that's okay. But neither of these two should use either of the ones side by side here. Okay? So I hit Command S, and I see something similar as I had before. There's no violations here. Build Tools has a dependency here, and that's fine, okay? But tomorrow, when somebody creates a dependency from Build Tools to addition KW for CPP, that will be a dependency on a group on the same row, and that is not allowed. That will be flagged as a violation. Okay, so that's a beginning of what you can start deciding on what way are your dependencies expected within your overall architecture. Okay. The other thing you can do is, if I go back, remember when I spotlit, for instance, parser.net here, I said there's a couple of .NET related modules here, but they're sort of mixed up amongst all the other modules. So that's not very clear here, okay? Now I can just do a bit of tidying up in that regard by taking .NET here. When I select it, I can follow the dependencies and quickly find there's one of the other .NET related, and there's another .NET related. I can right click on those and I can create a wrapper cell around those. This time I'm going to give it a name. I'm going to say .NET. Okay. So there's a wrapper cell called .NET. I can even give it a nice color so that we find it sort of stands out a bit. Command S, save that. And we come back here. And you might have noticed it got a little bit smaller, this top level structure here. And the reason it did that, because instead of having 3 separate modules in the visualization here, I now have just one module that groups together the other 3. Okay, so I've added a little bit of value now. I've made it maybe a little bit easier to understand. When I work on .NET, I tend to work on these 3 together, so that's kind of convenient. And I've given it a bit of color so it's easily identifiable by me and possibly my whole team, okay? Now, I'm going to show you the whole team aspect here, because actually these, let me go here, don't cancel, I want to go here. I'm gonna go dev. I'm just gonna go and find I think it's this one here. I'm gonna go here. These structure spec overlays are saved in XML files, okay? So at any point I can save them and share them with the team, but also, as you can see here, I can swap between them if I want to. So in this case, what I did was I just loaded up another structure spec file that I created in preparation for the demo. And what I had done here was, here's what I did just previously here. There's the .NET group that pulls together 3 modules, okay? And I did something similar for the Java. I said there's a bunch of Java related modules, so I put them together there. And I did the same for C++ and Ada and other languages that we have. And then I put all of these language packs here into another group. So I grouped the groups together into this languages group, okay? And so I did something similar with the vendors. Here are all the vendor related modules. And I can see here at a glance, for instance, we have a vendor, KW, Clockworks. We create a build of our products for C++ and Java, okay? For PRQA, they only get a C++. Coverity gets C++, .NET, and Java. Okay, so I can immediately see some architecturally significant information there. But I suppose more importantly now, it's sort of making the code base that bit easier to understand. Instead of having the big flat structure that I had before, by simply organizing my modules in that way, when I'm sort of browsing around the code here, if I command click on this, I see the dependencies of whatever I'm spotlighting. Let me go back to, was it this one here? If I follow, so it's following on, and switch around here. Now I'm seeing, I suppose, the same effect. I'm still getting the same spotlight information when I browse around my code base, but I'm seeing it through the organization that was created and is now overlaid on top of the visualization. Okay. Okay, and the other thing that'll be happening is there will be constant checking of any rules that are implied by my structure spec. Okay, one more type of rule that I want to show you, Command R here. One more type of rule I want to show you is that if at some point here I create, let's say, a new module. Okay, so I'm going to do that now here. I'm going to do File, new module from existing sources. Here, open that. So I'm just creating a new module. It's actually a module that was existing, but I'm just pulling it into my workspace here. Letting it update for a moment. And you'll see here, this is a module that, if I unspotlight here for a moment, here's that new module that I created. And you notice that it's sitting here now at the bottom of all the other modules that are in my structure spec, and it's red. Now that just means it's a violation in a sense that I've got a new module that's been created in the workspace, but there is no way to know at this point in time where that belongs. Is that intentional? Where does that belong in the layers? Okay, and the way I would add that then to the structure spec is, first of all, come over here. If you intend that to, now you may just want to leave that in place and say, no, I don't want any new modules. And then it continues to be a violation. However, if you're happy with that module and you actually want to add it to your structure, you can right click there and just add to spec. Okay, and you see the redness goes away. And then the next thing you'll want to do is decide where does that belong in your workspace. And you see it's a Coverity related one. So I'm going to add it here. Okay. Command S, come over here, and then that should be added into my, where I said that should belong. So that's inside vendor Coverity. There it is there. That's the new module. Okay. You can also create violations in a sense as you're making code, obviously. There's another way to express a dependency rule, and that's by using visibility. So let me just do that here. Let's say I'm looking here at this situation here. I've got a number of additions inside my Java code, addition modules here. One of them is being used by build tools, the others aren't. And let's say I decide that actually that's in error. That shouldn't be there. These ones here have no dependency from build tools. This one does. That's an accident. That was a mistake. That shouldn't be the case. I can make that private here. I can say, do you know what? Nothing outside of the Java scope should be using it. And I do that just by double clicking on public here. It's become private now. A little padlock has appeared here, and now you can see that the violation here has appeared. It doesn't go away, it's a dotted line, that's because it's a violation. And when I cut across here, it'll update. And now I'm seeing there is a red line from build tools to languages. And if I drill in here and say, where does that go? Okay, I'm going to give myself a bit more room. It goes into Java, and it goes in here. You can see there's the padlock there. Okay, so there's a violation here, and I can drill in and find out where's that violation, what's being used. Okay, this is being used, and I can command click there, spotlight it to see who's using it. ProGuard. This class here is using it. There's the problem right there. It's from this method. Okay. Okay, let me just collapse that away. Now, however, tomorrow, when somebody creates a dependency from build tools to one of the other addition modules here, that's not going to be flagged as an error. So the idea of the structure spec is to start being a bit more proactive. You don't want to be reactive. You don't want to be checking it every day. Put the rules into the structure spec and let the structure spec do the checking. Okay, so in this case, what I want to do is rather than make this individual module private, okay, let's make it public again. I'm going to select all of these here. And I'm going to shift click, right click, create a wrapper cell around those, and I'm going to make the whole wrapper cell private. Okay, see the padlock here now is on the whole wrapper cell, and I come across here. It'll update. I'll still see a violation here, okay? And when I drill in, I'll see it's still going, the violation is still going into the same module. But in this case, tomorrow, when somebody makes another dependency on any of the other additions, it will also be flagged as a violation, okay? Good, okay, so let's move on. That's the basics of the structure spec. Just to reiterate again, you can save these structure spec files anywhere, and we would hope that you do that so that you can save them with the code base so the rest of your team is working off of the same spec, the same view, the same metaphor for your code, the same rules apply across the whole team, okay? Good, now, what about ongoing improvement of your code base? Let's say you're here. How does this actually help you to improve your code base? Well, we've talked about violations, and anytime you create a violation, it will appear in here, in this spec violations list. So there's a number of viewers. You can, Structure101 Workspace viewers that you can make visible in your IDE workspace, in your IDE environment, okay? Spec violations is one of them, and you'll get a list of those. At the moment, we've only got one here, but that's okay. There are also some notable structures that become apparent even deeper than whatever you have specified. So inside your modules, you can catch tangles. So here's one here, top tangles. Here's my top tangles here, okay? If I double click on these, it'll take me down inside the structure here. It'll show me where's this tangle here. So there's one inside headway. The headway package here contains a tangle, okay? There it is there, okay? And inside headway.foundation, there's another tangle here that involves packages, okay? Now, I can go ahead and I can use these if I want to. This is often a really useful thing to do, especially if you want to start busting up very large modules. The first thing you often want to do is get rid of some of these cyclic dependencies so that your packages are not cyclically dependent, so that you might want to take some of those packages and move them up into modules, into new modules, okay? You can't do that if they're cyclically dependent with other packages, okay? So it's generally a good thing to do. How would you do that? Well, you would drill in, as I've shown you so far, okay? Let me show you as an example here. Here I've got CView uses widgets, okay? I can drill down into widgets to find out where does that violation go. I see it goes into Piccolo, it goes into somewhere, it's getting a bit busy, okay? It goes into layering widget. Where does it go inside layering widget? Oh, it's going down into get tooltip text, okay? So that's one way to do it. But I would encourage you to use spotlighting as much as you can. So in this case, I'm going in the other side and say, there's a couple of places here I can see that this feedback dependency is coming from, is going to. And I'm just going to spotlight that. Okay. And that sort of filters the whole thing. And now it takes me into layering widget. And now I can spotlight, get tooltip text. Okay. So by using spotlighting, basically, you can get to problems. It filters things a lot, so you can get to problems a lot quicker. Okay. And then it's a matter, if it's a simple problem, you might take a look, alt-click on that. Okay. And it takes me into here, and I can see, well, where's that problem coming from? I'm seeing there's a dependency here up to, right, from the widgets package into the CView package. And it's specifically a call to get identity string and get instance. They're the ones that are causing the problem. And over here, I'm seeing there it is there, okay? And in this case, it's a simple text manipulation. So at least syntactically, I know I can do that. That may not be what I want to do, but let's just see the effect of doing that, okay? And that has indeed removed that feedback dependency, okay? Now, that wasn't the only feedback dependency. If I collapse that away, I remove the feedback. So it was the dependency from widgets. There's still something else inside widgets. There's something inside layering, something inside Piccolo. That other feedback dependency is coming from here, okay? This is a class here that depends on some of the code in CView, but actually nothing else is using it inside Piccolo. So in this case, what I might do is alt-click on that, select that, and let's move this over to CView. So I'm going to refactor, move to CView. Let me go to, where's my CView? CView, let's move it to there. Refactor. Okay. Just give it a minute and let it recompile. And then we should see that class, that feedback dependency there will go away. I just need to hit a refresh. And if I collapse things away, I see now that indeed that feedback dependency has gone away. Okay, so widgets had a feedback dependency on CView. That's totally gone now. Okay, and if I look at my top tangles here, oh, where is it gone? A bit more room. It still takes me to here. Okay, because there still is a tangle, but it's got a lot better. Okay, it's improved a certain amount. Okay, and now I might work on disentangling these two items here. Okay, so that's how you might just generally sort of work on refactoring stuff. I'll just mention here that, by the way, those of you who use Studio will be aware that you can do some major simulation of refactoring activities before you start wading into the code. And that can save you a lot of time if it's a complex situation, okay? But for simple refactorings, you can certainly just use Workspace, look at the code. You can figure out by looking at the visualization and the code, how might I fix it, try it, and you'll see whether it worked or not. Of course, at any point in time, you can just undo changes or go back to your Git repository, abandon local changes and that type of thing. Okay. Another one that's interesting here is desktop tangles, top fat. Okay, fat is another measure that we use that you'll be familiar with from Studio. Okay, fat is basically just too much stuff in one place. Okay, and you can, if we take a look at one of these ones here, if I go to this high view package here, you can see there's the high view package here. There's a lot of classes in here, and specifically what it's measuring is the number of dependencies between the items within high view, okay? And it's crossing a threshold. The default threshold is 120. So there's more than 120 dependencies here. That's getting kind of hard to understand. And not only that, but it makes it hard to do the package level refactoring, because you've got, if you've got finer grained refactoring or finer grained dependencies, it's going to be easier for you to remove tangles and that type of thing. Okay. So in this case, what you might do, I'm just going to switch off auto build here. I recommend switching off auto build if you're going to do some major changes. Here you'll see that there's a whole load of classes here within HighView, okay? There's a few packages as well, but the packages are sitting on the top row here, okay? And the second row here, and down at the bottom, there's another package. But the classes themselves are all in a group in the middle layers of this package. And generally speaking, actually, it's my personal preference that if I've got a few packages, sub-packages within a package, I wouldn't also have classes here. I kind of like to have these classes also tidied away into a package. So let's just do that, okay? I'm gonna Alt-click on HighView here to go look at the package in the Package Explorer, okay? And I'm gonna select all of the classes in this package. Shift-click, right-click, refactor. Let's move those into a new package. I call it, they seem to be all to be do with high node. So I'm going to call it high node here. These are the high node related classes. Refactor, yes, please create the new package. Okay. Now this will take a little bit of time here. It just needs to move all of those classes. It's also going to do the refactoring. So it's going to connect up to all the imports again as needed. So we just let it finish. And it's updating the indexes because there's quite a lot of stuff got changed. And now we're just going to hit refresh because I had switched off automatic refresh. So I need to manually refresh now. And this time what we should see is that instead of all those classes inside HighView, okay, there's that HighView package again, okay? Instead of all those classes, I'm seeing a much tidier, easier to understand HighView package here with the high node sitting in the middle. And that's where all those classes are now, okay? So that's much tidied away. And in fact, the high node is no longer now, that high node package is no longer coming up on our list of fat classes, or the what's it called? The HighView is no longer on our list of fat classes. Okay, so this is goodness. That's, my code base just got a little bit better that way. Just by following these fat and tangles things, you can make ongoing improvements to your code base. Okay. Okay, so I think that's all I want to show you in terms of the sort of using it to do refactorings. I just mentioned a couple of important items, I guess, to do with performance. If you're working on very large code bases, you may well find that the performance drags, okay? So the first thing to realize is that while Workspace installs as a simple plugin to your IDE, behind the scenes, it's running the whole studio. You've got the power of the whole studio engine in a background server, okay? That sits there, it maintains a model of your code base, and that's what's serving up the visualization here. That's what lets us give you a live visualization of the code base in real time as it's changing, okay? That is running as a Java, it's a JVM instance running in the background. So what it may need to speed it up, if you have a million lines of code or whatever, then you're probably going to be okay. But if you find it's dragging a little bit, what you're going to do is you're going to go to, in the case of Eclipse, in the case of IntelliJ, you can edit custom VM properties. If you go to this file here, the VM options, and change down here, you see this DS101 server and DS101 GUI. These are the VM, this is the heap size for in this case, the server is the key one generally, okay? You're probably okay for the GUI. That's the heap size allocated to this viewer here. That'll be fine. But you may want to bump that up. And how much do you bump it up? It depends on the size of your code base. It depends on how much memory you have. We have several users with very large code bases who might bump that up to 4 gigs or even 8 gigs. If you've got a 32 gig machine, you might just want to do that for a while, okay? Okay, so that's one thing you can do. There are other things you can do performance-wise. If you have a very large code base, but you don't tend to be working, often this is the case. If you have a lot of Maven projects or whatever, you may not, your developers, each developer is most likely not working on all of them at the same time, okay? And what you can do there is you can go to the Structure101 settings here. Okay, so I just clicked on the settings bar here on the structure map. And inside here, you can see module scope, okay? And what you can do here is you can create, I think they call working sets in, or something along those lines, scopes in IntelliJ, maybe working sets in Eclipse. Create those through the normal IDE UI interface. You create working sets where stuff is exposed or not exposed. And then you can select them here. I don't actually have any set up, but oh, I have core only. So you would just change them here. And that will create a separate working set. So that the whole model is not getting loaded. You may already be using these, so you can just reuse them. I'll just mention that you do need to include if you have trouble getting this to work, just give me a shout, because there's a slight nuance here which I haven't time to go into here. But if you find it's not filtering, then just let me know. What it will do is it'll filter you'll still see your structure spec as before, and you'll see probably your top level modules, but you won't be able to drill in to the top level modules if they're not included in the selected working set, okay? The other thing you can do is overview mode here. This is quite a good one to just get a quick overview of your code base. It's actually fully functional. I'll show you here what that does. It's fully functional, but when you get down, if I drill into layering here, I see all the classes, the dependencies. I can navigate. I can alt-click on things here to navigate to the code. But I just can't go inside these things, right? I'll get this little message, item has no children, okay? So it can't be expanded. So it just reduces the amount of detail in the model. But that's really useful. If you've got your 10 million line code monolith, this can be a really useful way to start organizing your code base until perhaps you have broken up your monolithic module, or perhaps until you've created a suitable working set or a few working sets that you can switch between, okay? And I think that's about it. The one other thing I'll just mention here is if you are using Studio, okay, with Workspace, first thing to do is to use the Studio option. When you create a Studio project, select the option here. I think, can I show? I don't have it open at the minute, but you select the option to point it at a workspace project, and you're literally going to point it at this settings file here, okay? And then you'll have your Studio project will look identical to your workspace project, okay? So it gets all the information as found from within the IDE. As you know, with Studio, you can just point it at jar files and that type of thing. If you're working with Workspace, your best option is probably going to be to point it at this settings file here, okay? And create your Studio project from that, okay? The next thing you're going to do is you're going to save your Studio project in a Studio repository, okay? And then you're going to point to it from here, okay? And that'll just, that'll mean anything you save, anything you publish to the Studio repository, like the structure spec, like the architecture diagrams, like the action lists, will all be picked up from that repository, and they will be available to Workspace as well. Okay. And finally, I'll just point out down the bottom here, you'll see there's a few other viewers that you can get from, that all begin with the word Studio. So you've got Studio Actions, Studio Architecture Diagrams, and Studio Violations Breakout. They're equivalent to the viewers that you would may be familiar with from the IDE plugin, the simple lightweight plugin that you may have used previously with Studio. And they're all the Studio artifacts. That's where they end up. Okay. So now I'm just going to take a look. I see I have some Q&A. If you have any questions, guys, throw them into the Q&A right now, and I will, and I'll answer them at this point in time. So I'm just going to look here. One question here: how can I use the Eclipse plugin to resolve tangles in the existing code base? Is it exactly the same as you demonstrated for IntelliJ? Yeah, the answer to that is absolutely. It's exactly the same. You're obviously, the difference between IntelliJ and Eclipse are relatively cosmetic, really. You've got the icons here, you can see are the same icons that IntelliJ uses. In Eclipse, they'll look a bit different, okay? They'll look like the Eclipse icons for classes and methods and so forth, okay? All of the mouse actions that you're using in the viewer are going to be the same. Things that will different is, well, for setting up a working set or a scope in Eclipse will be a bit different. There's a different mechanism for doing that. The help sort of itemizes those kind of things. And when you're installing, I think, the view tool window in IntelliJ, this is where you reveal the various viewers that are shipped with Workspace. In Eclipse, I think they may be on the help menu or wherever you find your viewers. They're in a slightly different location, but that's it. Other than that, they're pretty much identical functionality between Eclipse and IntelliJ. Okay. Okay, that's the only question I'm seeing here. So what I'll say is thank you very much for joining this webinar. Please give me an email directly, chris@structure101.com will get directly to me. I'm really interested if you have any questions, what was sort of not clear about the webinar, or what other information would you like to see included in there? And in particular, when you start using Workspace and there's things that you found just a bit of a pain in the ass, just drop me a line and we might be able to improve the product a little bit. All that feedback is invaluable to us. And I'm more than happy to answer questions if you're wondering how to achieve a particular goal that relates to your own projects or whatever. Just let me know. Okay, guys, I'm going to call it a day at that. Thanks so much for coming along, and look forward to hearing your feedback. All the best.